welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. Right now, we have Daniil, who is creator of Gonka AI, and we'll be talking all about what Gonka enables and also your journey for getting into here. So I actually wanted to first start off about your entrepreneurial journey. I know you had quite a lot of diverse different experiences, starting from humanism and product science, and then also from Frank Money, and then you also did some work in AR, and then also did some product things with Snap as well. So curious to hear if you can tell us a bit more about your entrepreneurial journey, and then what led you to really focus on the decentralized AI space with Gonka.
Cool. I cannot hear myself, so I hope you can hear me. All right. So the entrepreneurial path of me and my brother David, usually this year is unusual for us because for the 40 years of our life, we mostly always together, the two of us on the stage or anywhere, doing business together since school, high school. And it all started with us actually building a decentralized network for compute somewhere back in 2002, 2003. Back in Russia. We were born in Russia. And then it was too early, honestly, for the cloud compute in that sense, especially because we were trying to build a network of user machines, like a type of a SATI project. And we managed to gather at the time 300,000 machines for doing some of the mathematical compute. Mainly, we were developing algorithms and which previously considered to be not parallelizable, and we were able to mathematically parallelize them. This was like sort of the thing which we saw the future, but then it didn't work as a business. Therefore, we needed to start thinking about something more practical, and we moved to games, online games. Still networks, still a lot of compute, but like understandable market in which you can actually make money. From games, like naturally moved to animation, because for games we build understanding of how to produce 3D graphics and animation really fast. And we used a lot of early machine learning, like computer vision, to actually produce the animation faster. Eventually, back in 2009, we've built the animation studio, which soon produced one of the top 5 most rated shows on entire Russian TV, a political satire of like weekly produced animated episodes, using a lot of machine learning to increase the speed of production of animation, of high quality of animation. And it wasn't just like AI generated at a time the way we see it today, but it was sort of early steps to like early, like before the actual understanding of what AI would be in the future. Then from that, there was this company which we sold to Snapchat, and we built the AR, surfacial AR tag for Snap, an avatar system for Snapchat. If you've seen Bitmoji, 3D Bitmoji avatars, that's us, we build them. And then when we left, we switched our gears towards efficiency of software code. And we started developing AI for software efficiency. And that was a moment when LLMs truly express themselves. And we realized that this technology actually will change everything in our life, like completely upside down world from what we knew before. And therefore from the very first business which we're building with decentralized networks, with decentralized compute, our idea was that decentralization is a guarantee for freedom. in not only in the sense of what happened with blockchains in the later on, like in 2008 9, but in general, the internet and the availability of information, uh, uh, the centralized nature of what we see with app stores or with mobile operating systems in general, or social networks in this sense, and monopolization in these informational layers, clearly not leading us in a great direction for as a humanity. Therefore, a couple of years ago, we sit down and we decided that we will use all of our knowledge of AI and decentralized distributed networks, to build a protocol for creating decentralized AI. I think that it was the moment when we realized that Bitcoin can be perceived as not only as a product of itself, as a digital gold, like a scarcity, a digital scarcity product, but also as a framework which allowed a peer-to-peer group of people, a decentralized group of people, invest hundreds of billions of dollars into building compute infrastructure, which today suppress something like 26 gigawatts of electrical power for only Bitcoin itself. And if we'll think about this through this prism, this is a financial framework for financing infrastructure. And as soon as we came to this conclusion, we decided that we need to build a network which utilizes this framework in order to build the network of compute which can compete with centralized players today.
Yeah, absolutely. And with these decentralized systems comes new opportunities as well, like with censorship resistance, like with more people being able to participate. So really love the vision there. And also really cool to hear that you and your brother experimented with decentralized networks from early on. And then it was exploring different markets, like with gaming, with animation, and then even looked into AR related work. So very cool to see the progression from there. I'm also curious to hear more about the current status quo with our decentralized systems. Are there any types of inefficiencies or limitations or even just general challenges that our current decentralized systems face that Gonka is trying to address, like say with incentive misalignment or any other types of inefficiencies that are present within our current decentralized systems?
I'd say that currently we don't experience their inefficiency in what we see in the existing centralized players like OpenAI or XAI, Anthropic. Like we can see that the people there are really brilliant and they are creating brilliant technologies. The danger is more in a centralization of AI, and we can see this even right now that they sort of taking the side in political decisions, like in political thinking as well. Like OpenAI would be more left, XAI will be more right, like creating biases towards beliefs. And it should not be the case for the technology which will completely change the life of all people in the world, not only in the United States. Therefore, I would say that the technologies which they develop in terms of AI models and AI applications is great. We just need to shift a little bit towards like the compute should not be. Think about this through this prism. Right now, NVIDIA sells 50% of all the newly produced GPUs to 2 companies in the United States. And then another 50% is mainly divided among another 3 companies in the United States. So like this is a significant centralization of the compute power. And because they are actually efficient, it might seem as if this is the only way. But what Bitcoin showed is that as soon as the framework is in place, and for this framework, it provides financial incentive for the players who provide higher efficiency in compute to get more money in this market. We see insane innovation. Throughout last 15 years, the efficiency of compute of the Bitcoin hash increased 300,000 times. From it used to be something like 15 million joules per 1 terahash to what is today 15 joules per terahash. So like 300,000 times more efficient compute than it used to be 15 years ago. Should we see a similar progression of innovation in AI within the next 5 to 10 years? What we experience right now in terms of efficiency of AI will be childish. Like everything which we have gonna be like 10,000 times more efficient, faster. Each of us will have the super intelligence available for ourselves for like $1 a month, $5 a month, not like thousands of dollars a month. Which like if some of you guys here are engineers, you know, like that for the cursor you need to spend like $1,000 a month if you actually use it efficiently. And the future might be completely different if the different competitive mechanism will be the force behind the market. And I'm not I can see how the existing companies will still be on the market, but the decentralized nature of the compute can and we all should fight for this to be decentralized. Can be decentralized, like the nature of the future compute can be decentralized, and we all should do everything possible for it to be decentralized. And all the players are going to be just using the same compute inside of the network for their models.
Mm-hmm. Yeah, absolutely. It's really great that you mentioned these current challenges now, because in the next few years, when we're getting more and more integrated with AI into our everyday lives, if we have continued situations like what you mentioned with NVIDIA only outsourcing their compute to 2 major companies, then it's really not allocated in that instance. And we're going to have a lot of kind of issues over there as well. And I really like how you mentioned that you see decentralized as a path towards achieving freedom, and how Bitcoin is one instance of using that tool as a completely new framework that we can model off of. So really like those points that you mentioned. I was also very curious to hear about the way that Gonka treats incentive alignment. So I know that Gonka has this very unique mechanism, the transformer-based proof of work using Sprint. So to my understanding, Sprint uses both a hybrid of proof of stake and proof of work, as well as giving the ability to allocate voting rights, voting weights as well. So was curious to hear more about the motivation for creating your own consensus mechanism and how that will really help enable for these decentralized systems.
Cool, yes. So I would flip it a little bit, saying it's not proof of stake and proof of work, but proof of work and proof of stake. Like making the proof of work the central part of what we believe might become the framework for building the infrastructure. As I mentioned, inside of Bitcoin, whoever was producing, let's say, 10 times more efficient compute, 50 times more, 15%, 50%, or 50 times more efficient compute would get a similar increase in the financial incentive they get from the Bitcoin, from the coins issued every day. So we decided that we need to apply the similar approach to this. But at the same time, all of this compute should not be wasted, and therefore this compute must be used for a practical jobs, which is majority of this practical jobs for a lot of us is inference of existing models. And then some percent of this should go for training for new models and increasing the capabilities of new models. So the approach which we decided to apply is how can we keep the 99% of the GPU power, of the compute power inside of the network reserved for actual jobs requested by the developers through the API, and yet be sure that no one can cheat. No one can actually pretend that if they actually have the compute capacity and they actually can produce the jobs. And we have both of this inside of the protocol. First, the sprint, by its nature, it's similar. It's almost like a 5-minute sprint to prove that you actually have the GPU or the compute power. For that, we developed a special algorithm, which is sort of like a Bitcoin hash, but a transformer-based one. And then after this 5 minutes, the weights of who actually have more compute is saved on chain and used as a voting power and the reward power for the future reward at the end of the day. And then during the day, the developers or like the randomly created load to the network, providing this load, providing the tasks, the actual real tasks for inference of specific open source, open weighted models. And then other participants inside of the network validate and verify the results. But we only validate and verify 1%, like every 100th of the tasks. And because this is like API requests for LLM models, during the day there are tens of thousands, if not millions, like in the future millions and probably even billions of the requests going through the network. Therefore, even when it's only one out of 100 tasks are checked, your particular node and your particular GPU is solving tens of thousands of them every day. And therefore, you are checked hundreds of times randomly, and you don't know who will check you and when will check you. And all those results are then in an interesting approach stored and verified on chain as well. We save several stages of the several vectors of the process of inference on chain to be able to prove that the result was real and true, so verified.
Got it. So there's some randomly selected tasks. You mentioned around 1% of them are actually verified on-chain, and that way you can save a lot of these on-chain verification costs that can incur.
Yep.
Got it. And most of the compute power, you mentioned around 90% goes towards the actual task
Compute
itself. Got it. Goes toward the actual compute.
Yeah. So it is constructed currently, and it can be changed by the voting of the miners in the future. Because as you mentioned, the miners then get the votes based on the weight of their compute, and through the internal dashboard, they can then vote for changes in the code and accept any update of the network as well. But then the way it's structured right now is that up to 60% of the network capacity, compute capacity, can be used by the developers completely for free. So every request through the API to the network will be solved for no payment. But then as soon as it reaches 60%, a mechanism similar to what Ethereum doing for the gas turns on, and the higher the compute above the 60% of the capacity, the higher the price of million AI tokens resolved by the model.
Got it.
But every developer can set the cap of like how much they are willing to pay. In this sense, it's sort of like an auction system. Whoever is ready to pay more at a specific level of the overload of the network is actually getting their tasks solved earlier than others.
I see.
And in this sense, we expect that the network will never achieve, like probably in some peaks, network will actually reach 100% of the load. But what we expect is that at least 20% of the network is going to be free most of the time. And this 20% can be used for training of open source models in order to make the network itself a place where newly offered to the miners community models will be accepted, and then training new models in a decentralized way. And over the past 2 years, it started to be clear that the new models can actually be trained in a decentralized way. First, it was DeepMind's, Google's article on DeLoco, and then several more upgrades proved that it is completely possible. We ourselves in a testnet trained, I think, up to 7 billion parameter model, and it was like a matter of like how many GPUs we have had in the testnet. Right now we have only 400 GPUs, but we started with 80 GPUs.
Okay.
So like in a month, the amount of GPUs grew 4 times. And if we are right with this, with the thesis of using the framework of Bitcoin to attract more compute, we expect that in a year this network might grow to up to 100,000 GPUs first, and then probably even to 1 million GPUs like a few years after that. And what we also expect is that in a couple of years from now, we will see, not even a couple, like in a year from now, we will see the emergence of the ASICs for the transformers. They already exist. There are already dozens of companies producing them. It just, they need a protocol and a framework for them to be able to start making money as soon as the chip exists. And we hope that we actually build the open source protocol which will enable such market for the producers of the chips.
Yeah, got it. It's really great to hear kind of the hardware side that you guys are addressing as well. And then, yeah, also very curious to hear in terms of, say, those entities, any kinds of new people who are entering into the network and want to provide compute, want to take on some new tasks. Do they still have the chance to take on these new tasks if there are, say, existing players already in the network who may have more resources to delegate to? I'm just curious to hear about, just for new entries of people who who have some compute and want to take on some tasks, how easy it is for them to participate.
So basically, this is a permissionless network similar to Bitcoin. You just need to install the node on your servers, and it's a little bit more complicated than Bitcoin just because it involves actual AI inference, and it involves actually having the system with installed drivers, with like a properly installed networks set up. So it's like a little bit more complicated, but we're making it easier and easier, more and more automated with like several updates already. But in like the vision is that it's going to be as easy as running a Bitcoin mining node in this sense. Okay, we'll use one mic. It's either off or battery. So okay, off. So what the answer to this is like the network is permissionless. Anyone can participate in the network. Currently, because there is not a lot of GPUs. Okay, 400 is already probably like, I mean, it's still not a lot, but we see that like a lot of our participants currently don't even own their GPUs, but they rent them from the existing GPU providers. And they basically like rent them for like half a year to a year in the future and mine the coins, basically providing the GPU power to the network. So in this sense, anyone with like a $50 or $100 a day, because this is the cost of the actual professional like H100 GPU per day if you rent it, can participate in mining.
Yeah, it's really great how you guys made it permissionless in a way where any kinds of new entrants can come and participate and delegate their compute. And the network is not really dominated by, say, just a few players who have a lot of resources or a lot of compute to delegate, but it's actually built in a way where anyone who wants to participate can. So yeah, I really like that design consideration you mentioned, and also about all of the tricks that you do for increasing the efficiency as well. Even for, say, you mentioned like maybe 20% of the compute is not being used, but that can be used towards training those models. So it's really great to see that all of the compute here is leveraged in a very efficient way. And just as a last question before we end today's interview, I'm wondering if you can speak about what's coming next for Gonka, and then also what still needs to be done to enable for more efficient decentralized AI systems. And if anyone in the audience is interested in getting more involved and learning more about Gonka, what should next steps be for them?
Yeah, so there are a couple more things which are still in the development, like end-to-end encryption. So we hope that in a few months from now, like maybe 3 to 4 months, we'll finish the part of the protocol which will enable end-to-end encrypted requests like end-to-end encrypted inference, enabling like the level of privacy which must be presented for the AI. Because if we will think about this right now, when we use OpenAI or XAI or any other company in the United States, by law, those companies are required to store all of our data unencrypted, available to be provided to the court or law enforcement. So should like anything of this will be like any of our conversation with AI might become public. And I'll give you an example. Like, you remember how several years ago Elon Musk said something about like taking his company private from public, taking Tesla, and then he was sued by the SEC. And during this process, all of his text messages and emails was published because of how the legal system in the United States works. So in the same sense, every single conversation you had with AI, with OpenAI, today already is stored, will not be and cannot be deleted by you, and accessible for the for public eyes. In a sense, someone is suing you. Like in a case, someone is suing you. So like to avoid this, decentralization is a requirement, and end-to-end encryption is a requirement, and that's like how we see some part of the future for decentralized AI networks. Another important part, which already there, like we couldn't launch before we actually achieved this, is because the results of the inference are, at least statistically, but with a increasingly, like insanely high chance of probability, verified. In this sense, we may say that the result of this inference is immutable, similar to Ethereum smart contracts immutability. And if we want to have the agents in the future, which we can trust with our money, bank account, like wallet, key, our kids' education, any possible, all possible variations of the private individual information, sharing this with our agents, we need to understand in whose interest those agents are actually acting. And in this sense, like if we don't have the immutability of the results of the inference, we cannot trust to the to some level of extent whose decision is actually executing the model behind our request. And then how to participate? Mine, like go and like you can go to gonka.ai, find all the documentation. I know it's like very unfriendly at this stage because it's like engineers project, but sooner or later we will make it easier for literally everyone to be able to participate in mining, because it's a permissionless network.
Absolutely, and thank you so much, Daniil, for being here and for speaking with us today with all these insights. And yeah, I really appreciate all of the strides that Gonka is working to making using decentralized as a tool to further strengthen AI, and using the decentralized component as a verifiable mechanism as well. So thank you so much, Daniil, for all the insights.